Hello, welcome to today's class. This class is about descriptive analysis. This is the class outline. We'll talk about descriptive analysis. I'll touch different examples of descriptive analysis, and I'll also talk about data visualization. So for this class, you need your writing materials only. We will not be working on any application. From next week, we are going to carry out descriptive analysis with the different applications, SPSS, DraftPad Prism, and Microsoft Excel. This is the class objective, and then let's get into class. So what is descriptive analysis? Descriptive analysis deals with summarizing, organizing, and then visualizing your data. This is to show the basic features of your data set, and then it helps to actually provide insight into your data by highlighting patterns and then showing the distribution of your data. Okay, so now when you have a large data set, let's say you collected data from maybe 100 samples, 100 respondents, or even 500 respondents, you cannot present that data that way in your project or in your research. You need to actually summarize it to make it more concise so that you can actually present it effectively. This is what descriptive analysis is about. It's about summarizing and organizing your data. So after summarizing and organizing your data set, you also need to actually visualize it. That will also help in communicating the information in your data better. So it's very important to note that descriptive analysis does not make inferences or prediction. Okay, we have different examples of descriptive analysis. We have the measures of central tendencies, for example, mean, median, mode. Then we have the measures of dispersion, range, variance, standard deviation, interquartile range. We also have shape of the distribution, so you can use that to describe your data also. This is where we'll talk about skewness. And then data visualization, you can visualize the data using different type of charts, like the bar charts, like the column charts, like the scatter plot, like the pie charts, and so on and so forth. Then we also have frequency and percentage, which is actually very important. For most of your data, you'll be creating frequency tables, which is a table that will contain a particular variable and then the different categories in the variable, and then the frequency of the different categories in that variable, then the respective percentages. You'll be doing that a lot. So now moving on, I'll talk about each of these in details. Measures of central tendencies. These are actually single values that are used to summarize numerical data and represent the center or middle of your data set or of your variable. But the examples are mean, median, and mode. So let's assume you collected data, maybe age of students in a class. So we have 100 students in that class, and then you collected data of just their age. So that means you have 100 rows of data that is for age of each person in that class. Now, if you want to talk about that particular data set, you cannot actually list out the 100 data or present it that way. You have to find a way to summarize it, and then you will need a single value that you can use to describe the age of the people in that class. So in this case, you can use measures of central tendency like the mean, like the median, and the mode. So that I can say something like the mean age of students in so class is this, or the median age is this. Mean refers to the sum of the values in a data set divided by the numbers of the values in that data set. For example, the age I mentioned, if you gather the age of 100 students that are in a class, then you have to add up the age of all the 100 students and then divide the result of that by 100. That way, you'll have gotten the mean age for that particular class. While median refers to the middle value of the data set when it is actually ordered ascending or in descending order. Now, if in the case of a class of 100 students now, we are going to have two values in the middle of that particular data set because the total number is an even number, which is 100. Assuming it is 99, then we are going to have just one middle value. But because it is 100 and then has an even number, we are going to have two middle values. And then to get the median in that case, you have to find the average of those two middle values. Why mode refers to the most frequently occurring value in your data set. So this is an example. So now we have a class that contains 100 students, but 20 of those students were actually sampled, and then the mathematics exam score was recorded. And these are the scores here that I've listed out the scores here. So how can we calculate the mean in this case? To get the mean, you have to add up the individual values and then divide the sum of that by 20. So the sum of this individual score is 1358. Then dividing by the total number of people sampled, which is 20. The mean is 67.9. Now for median, you have to order the data either in ascending or descending order. You order the value now from the smallest to the largest value, and then if you check 67, these two values are the middle numbers. So because we have two middle numbers, we have to find the average of these two by just dividing their sum by 2, and then it still gave us 67. So the median in this case is what? Is 67. Why for the mode? That is 53, because 53 occurred 3 times. Some other values like 45 and 92 occurred twice, while other values occurred just once. So 53 occurred 3 times. So that is the mode of this particular data set. So now going to measures of dispersion. So these are actually single values also that represent the spread of a data set. After getting the measure of central tendencies like mean, median, and mode, it's actually very important to actually understand the variations in a particular data set that we are working with. So different data sets or data of different samples can have the same measure of central tendencies, but that does not mean they have the same spread or they have equal variation. I'm going to show an example in the next two slides. So for measures of dispersion, we have range, we have variance, we have standard deviation, and then we have interquartile range. So for range, this refers to the difference between the highest and the lowest value in a data set. And then for variance, this is the average of the squared differences from the mean. So variance, this is the average of the squared differences from the mean. We'll get what that means better in the next two slides. And then standard deviation is the square root of variance. It represents like the average distance from the mean. Then we also have interquartile range, which is the range between the first quarter and the third quarter. The first quartile is the 25th percentile, and then the third quarter is the 75th percentile. All these values, the range, variance, standard deviation, and interquartile range, they have formulas, like mathematical formulas, that shows how you can actually calculate them by hand. But we don't really need to bother our head too much about those mathematical formulas, because really we'll be using applications to actually compute all of that. It's good to have the basic idea of how the formulas work, but we'll be using applications to do the calculation, so we might not bother much about like knowing how to calculate it by hand. So another thing that is very important is actually knowing how to interpret these values. So if you run your analysis and you got variance, you got standard deviation, range, interquartile range, how can you interpret all of these values? That is also very, very, very important. Now, example for measures of dispersion. So we are still using the same data set of the exam score, and if you look at that, for the range, which is what the maximum value minus the minimum value, the maximum score is 92 and then the minimum score is 45. So the range for that particular data set is 47. And for variance, so the explanation here says this is the average of the squared differences from the mean. So the way to calculate variance by hand is you first need to calculate your mean. So when you know your mean, then you need to have, so this is the column that is representing the exam score, and then we have the column representing the deviation, which is what x minus mean. So our mean here is 67.9. So to get this now, that would be 45 minus 67.9. I think something is wrong with this column. It's meant to be minus 22.9, 0.9. I hope we get that. Okay, so you have to do deviation x minus mean. So your value minus mean, that will give you the deviation, and then you have to find the square of the deviation, which will be this raised to power 2. And after you've gotten all of this, then you need to get the sum of that. In this case, we still need to do for the individual values, and then the sum of everything. Slide will not contain the table, so I just showed few examples. So after getting all of this for each value in the data set, that means for the 20 scores, then we need to sum all of this together. That is the squared deviation, and then the sum of that will give this. Then now the sum of this will now be divided by n minus 1 or n. So if you are working with sample data, then you are going to divide the sum of the squared deviation by n minus 1. But if you are working with population data, then you just divide by n only, and then this is variance for this data set. So now standard deviation is square root of variance, so you just need to find the square root of variance that we've gotten here to get the standard deviation. Okay, I know this might not be still making sense yet, so going to the next slide now. The next slide is going to show us like what's really the importance of this. Why do I need to find range? Why do I need to find variance or standard deviation? What's the use? What's the importance? We have two data sets here. Let's still call them data sets for scores of students. So we have data set 1 and then data set 2 that all refers to scores of students. So we can see that the two data sets have the same mean, which is 61. So we can say, oh, maybe this data set 1 is for class 1 and then data set 2 is for class 2. So we can say on the average the students scored 61. And for data set 2 we can also say the same thing. But if we now look at the measures of dispersion, you can see that variance of data set 1 is 36.67, while the variance for the second data set is 57.11. So the higher the variance or the standard deviation, the higher the variation within the data set. And if you look at the standard deviation also, for data set 1, that is 6.06. But for the second data set, it is what, 23.90. Now what this is telling us is that the second data set had more variation compared to what, to the first data set. And we can actually see it like clearly here. The smallest value is 52 and then the largest value is 70. While for the second data set, the smallest value is 30 and then the largest value is what, is 100. So if we are going to look at these two classes, even though they have the same mean, if you want to judge for the class that is actually doing better, that will be what, this first class, because their variance is reduced, the scores are still closer to each other, and they relatively still like have higher scores. While for the second data set, we have some large values like the 90, like the 100, that affected the mean. You know the way mean is calculated, right? That kind of now shifted the mean upward. So now this is taking me to another point, that for different data sets, we have three measures of central tendency: the mean, the median, and the mode. What you inform your decision of you want to use in describing a data set is dependent on reasons like this, such as like the variation within the data set. So in this case now, mean is not exactly a perfect value to describe this data set, because we have extremely large values and extremely low values in the data set. So in this case now, it is better to describe the data set with the median. That will describe the data set better. So if you calculate the median for this now, I believe it should be around 60 something for this first data set, while the one for this second data set will be around 50 something. So at least that is showing us that on average these students, they scored higher than these students, which is like the true look of things. Another important thing about descriptive analysis is the shape of distribution of your data, and that is the skewness. So we have your data can be distributed, can be normally distributed, it can be negatively distributed, which is also known as left skewed, and the data can be normally distributed, it can be left skewed, or it can be right skewed. So For each, for example, for right skewed or a positively skewed data, the mean is greater than the median, while for a negatively skewed data or a left skewed data, the mean is less than the median. So we'll see the examples of these distributions in the next slide. So here now, this one is a normally distributed, this data here is normally distributed. So you can see that this is an histogram. So if you want to show the shape of the distribution of your data, a visualization that you can use to show that is what is, and you can use histogram. That's a very good visualization to show that. So and for an histogram, the y-axis represents frequency, while the x-axis represents the different values in the data. And for a normally distributed data, something like this. So the smaller values have like lower frequency, and then the middle value have higher frequency. Then the very high values also have lower frequency. So that results in a shape like this. For a left skewed data, we have more of the high values, like something like this, and then for a right skewed data, we have more of the low values. Now going into data visualization, there are different ways by which we can visualize our data in descriptive analysis. You can use bar chart. This is a bar chart. This is a bar chart. You can use pie chart. You can use histogram, which is what I've shown before in the previous slide. You can use line charts. So line chart especially is good for data that has to do with time. A line chart is good for data that has to do with time. Yes, for example, dates, months, data that want to show trend. Okay, then we also have column charts. Then we have scatter plots, which is a chart that can be used to show relationship between two numerical variables. So now we have frequency and percentage. Most times you'll be creating frequency tables. You'll be creating frequency tables for your demographic data for the different sections in your questionnaire. You create frequency table. So frequency refers to the number of time a particular value occurs in a data set. Then the percentage refers to the proportion for that specific value relative to like the total frequency of the data set. And relative frequency is just like percentage, but in form in decimal. So a frequency distribution table will actually contain a variable, the different categories in the variable, then the frequency and the percentage. So I would like to talk about univariate versus bivariate analysis. Univariate analysis, like as the name implies, uni means one and then bivariate means two. Univariate analysis is when you are analyzing just a single variable to understand its distribution, central tendency, dispersion, frequency, relative frequency, proportion, and all of that. For univariate analysis, you are just analyzing one single variable. For example, I might just analyze age to know the mean age, the median age, the mode, the standard deviation, the variation among the age in the data set. So that is univariate analysis. Bivariate analysis refers to when you are trying to analyze two variables together to kind of see if there's a form of relationship between them. So the scatter plot that can be used to show relationship between two numerical variables, that is like a form of bivariate analysis. Sometimes we can use cross tabulation. We'll see that later on. And then a compound bar chart or column chart can also be used to analyze two variables together. So in the first class, I mentioned that types of data, it actually determines the descriptive statistics or visualization that you can perform on that particular data or on that particular variable. Now, for a nominal data, you can find the mode. You might want to know the group or the category that occurred the most in that particular variable. Also, you can find frequency and percentage. That's done in this slide. Okay, so then for data visualization, when you find the frequency for each category that occurred in the variable, then you can actually turn that into a visualization to create bar charts, column charts, or pie charts. For ordinal data, the same thing applies also, which applies for the nominal data. But for ordinal data, you can also get the median, you can get the middle value. For discrete data now, which is the numerical data, you can find median, you can find mode, You can find mean, you can find methods of central dispersion like the standard deviation, variance, and then to visualize it, you can use bar chart, column chart, you can use histogram as I've explained before. You can also use box plot charts, which is not in this slide. You can actually check online for how that looks and how to interpret a box plot chart. For the continuous data, which is also a numerical data, you can also find the mean, median, range, standard deviation, variance. Then you can use histogram, box plot, scatter plot also to visualize continuous data. So this is the end of today's class. That was introduction into descriptive analysis. That's a summary of what descriptive analysis is. I hope you learned something new from this video. I hope you learned something from this video. If you have any question, you can actually ask your question. Comment under this. You can comment under this video, or you can ask me online. You can tweet and tag me on Twitter. So tomorrow we're having a special person that is coming to take us. So Abefe, the statistic guy, is coming. He's going to teach us inferential statistics, and you don't want to miss tomorrow's class. So see you in class tomorrow. Abefe will see you in class tomorrow. Okay, bye.